Hello and welcome to this video. The combination of machine learning and Flutter is very powerful. It gives you the necessary tools to create an intelligent application. In this video, we are going to see how we can integrate machine learning into Flutter. First, a brief overview of what machine learning is. In machine learning, the computer is trained using specific algorithms for a specific task. For example, recognizing objects or classifying images, for example, dogs and cats. After the training, we will have a model. This model is trained based on our data, and now we can feed this model new data. And we input the data to this model to get the output. The output, for example, can be dog or cat. Machine learning is a huge domain in research, in variety, and in complexity. We know that Flutter and Firebase are perfect match for lots of services that Firebase is offering. And in machine learning, if someone wants to start building and developing an app that has machine learning integrated into the application, it's a good start. Firebase machine learning is backed by Google platforms like Google Cloud Vision and Google Automl. As a beginner, you don't need to deal with complex machine learning issues and algorithms and coding and getting some errors. Google made it very simple. There are 3 ways to add machine learning to your Flutter application. This is the first video of series of videos that we are going to talk about machine learning. So subscribe to make sure that you follow other videos as well. The first one is machine learning APIs, which use pre-trained machine learning models. These models have been trained by Google on their data, and they are ready for you to work with, ranging from text recognition to face detection. You can make use of these APIs by just simply feeding data as an input and getting the output from the APIs. The second way is to use Tensorflow Lite with Teachable Machine. In this option, you train a custom model using Tensorflow Lite. TensorFlow is a framework that Google uses in their infrastructure for their services, and they have published access to public. You can download it as a Python library and use it. And in this second approach, you can use TensorFlow Lite. They announced the Lite version that is suitable for mobile devices. We can train our model using Teachable Machine because TensorFlow is pure coding. You have to code from start to end. So using Teachable Machine is going to be very easy for you to train the model. Teachable Machine is a web-based tool. It's graphical user interface that helps you create and train models fast and easy without the need to code for the training. And the third way is using Cloud AutoML Vision. In this approach, you can use Cloud AutoML Vision to train your custom model. Similar to Teachable Machine, you can train custom machine learning model fast and easy. And this service is generally used for more complex use cases, which cannot be done with Teachable Machine. And back to the first approach, which is covered in this video, it is machine learning APIs. The Firebase provides many pre-trained models that you can choose from. You just need to get the model and input your data to get the output. And they have 2 approaches. One is the offline mode, where you can download the model to your mobile device as part of your application, and the user can perform the task, whether it is image labeling, text recognition, all offline without the need for connectivity. And the second approach is to use connectivity and to use cloud-based APIs. And in terms of pricing, you can run APIs like text recognition for free for on-device use, and you can use cloud-based APIs for free for the first 1,000 uses per month. And as I mentioned, you can choose between on-device and cloud-based, and based on the complexity of your application, you can decide which one to use. If it is a simple use case, you can use offline version, which is less accurate than cloud-based version. And if you need more complex model, you can use cloud-based API, but of course you need the connectivity compared to the on-device models. Now let's code and see how we can develop an intelligent Flutter application. I have to mention that on June 3, 2020, Firebase team announced that they made some changes to ML Kit for Firebase. They actually separated ML Kit, which is the on-device APIs, and Firebase Machine Learning, which is focused on cloud-based APIs. So we are going to follow this approach, and we are going to focus on ML Kit, which is the on-device APIs. You can go to developers.google.com/ml-kit. They mentioned that the algorithms and their model is optimized for mobile. It is built with Google expertise, and it is easy to use. And they have different categories. For example, the first one is Vision APIs. In Vision APIs, you have many services: barcode scanning, face detection, image labeling, text recognition, selfie segmentation, pose detection. We are going to focus on image labeling in this video. And they have a category of natural language APIs, language ID, on-device translation, smart reply, and entity extraction. The way to implement these services are almost similar. So we are focusing on image labeling in this video, and the principle applies to other services as well. Just some code need to be changed. I'm going to leave the code for some of the services in the GitHub in video description, so you can check it out. So in image labeling with ML Kit, we have to follow some steps, and then they show that we can prepare the image and process the image. But this one is in Java and for Android. We are going to code in Flutter. But first, we need to do some preparation. First is to go to Firebase and create a new project, and then go to project setting, and you have to add your app. You select Android, you add your package name. The way to get the package name is to go to the Android folder of your project, and then go to app, source, main, and you have Android manifest.xml. Here at the top you have the package. This is your package name. You just get the package name and you paste it here, and you click on register app, and then you need to download this JSON file. You download this JSON file and you put it in the Android folder. You open the app and you paste it here, and this is the JSON file. And the next step is to make some changes to the project level Gradle file, which is available at the Android, and build.gradle. You need to follow these steps and add Google and class path and Google. Make sure that you have all of these. And then you go to the app level Gradle file, which is inside app. You open the app folder and it is here build.gradle. And you follow these steps to add these requirements. And then you click next and then that's finished. And you can add app one more time and for iOS. You can add your bundle ID, which is available in Xcode. You can go to the Flutter project and right click on iOS and you have the Flutter and it shows the option to open the code in Xcode. In the Xcode at the top on the left side, if you click, you can see your bundle ID. You just copy and paste that here and follow the instruction same as Android. And then once you add your app and register your application in the Firebase, we go back to the documentation and there are some preparations that we need to do. First, we need to go to the app level Gradle file, which is inside the Android, inside the app, this one. We need to add this implementation in the Dependencies section. In the Dependencies, we add this line. And this is going to download the model from Firebase and add it to your project. And if you want to dynamically download the model from Google Play Services, you need to add this one. And also you need to make some modifications to the Android manifest.xml. The next step is to add our dependencies inside pubspec.yaml file. Under Cupertino icons, we are going to need Firebase ML Vision. You can go to pub.dev and search for Firebase ML Vision and go to installing and get the latest version and add it into this file. We are going to need image picker so the user can pick an image from their device so we can label them. And also we are going to need Firebase core for some core services. After this, you click on pub get and it's done. And then we are going to lib folder main.dart. Here we are going to code for the application. This is the application we are going to build. When you first create a default application in Flutter, you get the counter application and you have this floating button. We are going to use this floating button and ask the user to select an image using this floating button. We are going to have the image here and we are going to have the labels underneath the image. First, we need to import some packages. One is material and another one is image picker. And then we are going to need IO and Firebase ML Vision. First, we have the main function and then it goes to the My App. Inside the My App, we have Material App and then Theme Data and then Home. Inside the Home, we have My Home Page. In the My Home Page class, we are going to define file image for our image. We are going to define picker and we are going to define a variable of type image labeler. And then we need to have a variable for result. And inside the build, we have scaffold and we have the column. The whole application, we consider it as one column. And the first child in the column is a container. Inside the container, we are going to center the content of the container and then we are having the ternary operation. This is the same as if-else statement but in one line. This is the condition. It says that if the image is null, which is right now when the application is launched, then we will have a text widget that says no image selected. Otherwise, if the image is not null, there is something in the image and user has selected the image, then we are going to have the image widget that shows the image that user has selected. And then we have the sized box to have some separation between the widgets. And then we have another container with center widget. This one is also ternary operation that says if the result is null, then we are going to have a text widget that says nothing here. But if it is not null, then we are going to have the text widget that shows the result. And after this, we have the floating action button. And in the onPressed, when the user pressed the button, we are going to call getImage function. In the getImage function, we define it here. The return value is future. And the function is asynchronous. So we have async and we have await. If you are not familiar with this topic, you can watch this video at the top right corner about the asynchronous function in Flutter. And we define picked file and we have await. Why we need to have await and asynchronous function? Because we are waiting for the user to select an image. So we need to wait until the user takes action. And then we have picker.getImage. And then we define a source. In the source, we say image source.gallery. You can actually have the source of the image as gallery or camera. We're going to select the gallery. And after the user selected an image, we need to refresh the app. We need to change something in the app and show the image. So we are going to call setState. Inside the setState, we check that the image that the user selected is not null, and then we assign the selected image to image file variable, and then this line is going to show the image on the display. And we are going to call process image labels. Or if the image that the user picked is null, then it's going to print no image selected. After the image is selected, we call process image labels. This is another function. It is asynchronous because we send the image to the model and we wait for the result to come back. We are going to define Firebase Vision Image variable, and we are going to send the image to this function Firebase Vision Image, and then we are going to have Firebase Vision.instance and image labeler. This is an object, an instance of image labeler class, so that we can use it in the next line, labeler dot process image, and we provide the image, and we have the result in the image labels. The result is going to be in the form of couple of labels, so it's not one result. And we are going to have a for loop to go through the labels inside the result, and for each one we are going to add the label to the result, which is initially empty. And now that we have the result, we are going to show it on the screen, and we need to refresh the app, so we call setState. In the setState, for each label we are going to add it to the result variable. And after we add it to the result variable, the result is going to be displayed on the screen. Now, if you try the application and click on the floating button, we can select an image from gallery. I added these images in the emulator. If you are using emulator and you want to add an image to the gallery, you can go to this tab, Device File Explorer, and then you go to SD card, you go to download, and you right click and you select upload, and you select your image and you click OK. The image is going to appear in the emulator, and we are going to select, for example, this one, and we have the labels that came from the model. It says food, cuisine, fast food, bread, vegetable, cheeseburger, meal, fruit, and flour. And these numbers are the probability of having this category and this label inside the image. In this case, it is 93% chance and probability that there is food in this image, or 86% probability that this image shows cuisine, or 52% probability that it shows fruit. These labels are sorted from the highest probability to the lowest probability. You can think of applications that you can develop using this feature, image labeling. And your app is going to be intelligent, and it can, for example, categorize large sets of images into different categories. Let's choose another photo, for example, this one. The labels are aviation, aircraft, airplane, vehicle, and so on. And this one, it's 99.5% probability that this image shows cat and pet and dog and fur. So that's the way you can integrate machine learning into your application. We're going to have lots of videos about machine learning in this channel. Please subscribe so you don't miss them. Thanks for watching. I will see you in the next video.